What's with this? Who left these shapes all over my screen? This is a terrible organization. We gotta get this organized. All right, well, first off, each one of these is a polygon, and each one of these has 4 sides. That means they're all quadrilaterals. So we're gonna start off, let's see, big loop, big loop. We're gonna call them all quadrilaterals because that's what they are. These are all quadrilaterals. Of course, some of these quadrilaterals are more equal than others. Now we got some squares there. All the angles are equal. All the sides are equal. Got a rectangle. All the angles are equal. A rhombus. All the sides are equal. Parallelogram. Oh, we got a whole mess of parallelograms. Opposite sides. Both pairs of opposite sides are parallel. That's a parallelogram. But the rectangle, that's a parallelogram as well. So there's each of the squares. That's a parallelogram. You know, we'll put all the parallelograms together. That's a good idea. Let's do that. Let's see. We're going to put all the parallel, move this trapezoid out here. And all the rest of these are all parallelograms. You know, the squares, rectangles, rhombus, these are all parallelograms. Each one of these, the opposite sides, they're parallel. I'm going to use a different color for that. I'm going to grab some yellow there. And we're going to make a big loop there. And we're going to put all the parallelograms in here. Parallelograms. Of course, some of these parallelograms have some special features as well. And well, there's a rhombus. That means all the sides are equal, but well, the squares, all the sides are equal as well. So the squares are rhombuses too. These three, though, these three aren't rhombuses. The sides aren't all the same in those. So we should separate those off. So let's do that. Let's put these 3 over here, bring my 3 rhombuses over here, and these 3 things over here are not rhombuses. So I can make a loop for the rhombuses. I can make a loop just for the rhombuses. All right, great. We're going to use red for rhombus. Red for rhombus. All right. Make a loop just for the rhombuses. There we go. Or is it rhombi? I'm not sure. 2 years of Latin, totally wasted. All right, rhombus. Let's see. Rectangles. We've got rectangles too. There's a rectangle, but the squares are rectangles as well, but the squares are already inside the rhombus loop, so I can't also put them in the I can put them in both loops. I can put them in a rhombus loop and in a rectangle loop if I make those loops overlap. So that's what I'm going to do. I'm going to grab another color. Let's go with some kind of yellowish green here. And I'm going to go like this. I'm going to make a rectangle loop. And where the rectangles and the rhombuses overlap, that's our square. So I need to move this square in here as well. There we go. We got our squares. Each of these squares is a rectangle. Each of these squares is a rhombus. So those squares have to be in both loops, and we have to leave these 2 parallelograms outside of both of these loops. They're parallelograms, but they're not rectangles or rhombuses. So we can go ahead and label that. Let's see, let's grab another little color for that, and we'll call these the squares right in here. So now we have it all figured out pretty much. All of these shapes are parallelograms. They all live inside the parallelogram loop, and the whole parallelogram loop lives inside the quadrilateral loop. So all the parallelograms are quadrilaterals. Every rhombus is a parallelogram, so all the rhombuses are inside the parallelogram loop. Every rectangle, also a parallelogram, so the rectangle loop inside the parallelogram loop. The rectangles and the rhombuses overlap. When a quadrilateral has all 4 sides equal and all 4 angles equal, we call those squares. Wow. All right, nice and organized. Except for this fellow over here. It's trapezoid. 1 pair of opposite sides there. These 2 sides are parallel. Now, parallelogram. Yeah, you recognize this as a parallelogram. Now, watch this. We'll grab point B, and we're going to slide it along. Still a parallelogram, right? Opposite angles, add to 180. These 2 add to 180. These 2 add to 180. These 2 are equal. These 2 are equal. This is still a parallelogram. Oh, we slide all along here. Still a parallelogram. Still a parallelogram. Wait. There's a spot back here. A spot back here where all the angles are 90. Is it still a parallelogram? Of course it's still a parallelogram. These 2 are parallel. These 2 are parallel. This is still a parallelogram. It's also a rectangle. Just because it's a rectangle doesn't mean it stops being a parallelogram. All right, so we go parallelogram, parallelogram. It's a rectangle, but also a parallelogram. And we can do that all day long. We slide these things all over the place. We get the same thing. We're always a parallelogram. See, still a parallelogram. Now, we go back to here, where we were a rectangle. We're still a parallelogram. Now, watch what happens when I move this up. When I just take this side, if I can grab it, and I'm going to move it up. We get to this point up here where all the sides are equal and all the angles are equal. It's still a parallelogram. It's still a rectangle. It's also a square. It doesn't suddenly stop being a parallelogram the minute it becomes a square. It's still a parallelogram. It's a square. And it's still a rectangle, but it's also a square. Now let's talk trapezoids. All right, so now I'm going to show you their world. In their world, we're sliding along. This is not a trapezoid. They say parallelogram, not a trapezoid. In their world, they want all the trapezoids over here. They want to keep the trapezoids separate. They'll let them get real close to the parallelograms, but nary the twain shall meet. And they'll let their world look like this. Trapezoid over here. And they'd even be sad about me letting this name run into the parallelogram space. That's their world.